exercise 4a, question 9. We've been asked to find the binomial expansion of 1 minus 3x to the power 3 over 2. So 1 minus 3x to the 3 over 2. So identifying our x, that is the minus 3x part, and our n is 3 over 2. So straight into what hopefully by now in this exercise is quite a well-known formula. 1 plus n x, as usual, x goes in a bracket with its sign. I've got 3 over 2 half over 2 minus 3x plus 3 over 2. Oh, nearly missed my squared. 3 over 2, a half minus a half over 6, 3 factorial minus 3x cubed. Okay, so I've got, remembering that my equation is, if we're talking about, say, this part, n minus 1 over 2 factorial x squared. Okay, and the next one down, n minus 1, n minus 2, and so on, following the pattern. So let's neaten that up. Okay, 1 minus 9 over 2x. Okay, I've got 8, so 27 over 8 x squared. Again, 2 minuses, that makes a plus, and I have got 4 minuses on the next one, so that makes a plus again. I've got 27 over 16x cubed. Okay, so and show that we've seen one of these before in the exercise. Again, slow and steady, using your SIRD knowledge from first year and GCSE. So I've got 1 plus 3x, sorry, 1 minus 3x to the 3 over 2, and I'm going to substitute 1 over 100 in that. So I've got 1 minus 3 over 100 to the 3 over 2. Again, I'm going to go very slow and steady. That's 97 over 100 to the 3 over 2. Now, let's deal with the over 2 part. The over 2 part means square root. I'm going to do that first. So that is the square root of 97 over 10 cubed. Now I have done 2 steps in one, so if you prefer, I'll just show you the interim step. So what I've done is applied the square root to 97 over 100 cubed. And then, of course, the square root of 97 is just the square root of 97, but the square root of 100 is 10. Okay, now at this point, what we're aiming for is to be over 1,000. Now, the 1,000 is easy. 10 cubed is 1,000. Root 97 cubed, that's root 97. Let's just do it above. Root 97 times root 97 times root 97. So those two combined will make a 97 root 97, and that's as required. Okay, so the next and final part of this question is substitute the 1 over 100 into the binomial expansion to obtain an approximation for root 97. Now what we need to realise at this point is that if I put 1 over 100, okay, so x equals 1 over 100, into my expansion, okay, which is 1 minus 9 over 2, 0.01, plus 27 over 8, 0.01 squared, plus 27 over 16, 0.01 cubed, that will approximately be equal to 97 root 97 over 1,000, because what we've already shown in part B is that if I put 1 over 100 into 1 minus 3x to the 3 over 2, I don't get root 97, I get root 97 times 97 over 1,000. And this is quite a standard exam style question. I've seen it so many times. And what you've got to realise is that when you sub in, you need to think about your expansion and your function. because when you put 1 over 100 in, you put it into both the expansion and the function and compare what you get. I don't get root 97, okay? But if I want an approximation for root 97, that will be this whole chunk here, my expansion part, which unfortunately is the one bit I didn't think to do earlier. So let's quickly stick that in a calculator. 0.01 plus 27 over 8. 0.01. This is like speed calculator typing, and hoping I don't make a mistake. 27 over 16. 0.01 cubed. So it will be my 0.95539. Again, I'm going to keep a lot of decimals until I know, but I need to times it by that 1,000, okay, because I need to bring that up to the other side, and divide by the 97. So if I times that by 1,000 over 97, I get the fact that root 97 is approximately equal to 9.84886. Yep, quick check, did want 5 decimals. I thought it might. Okay, so you've got to be super careful, but actually if you realise that you put your x value in both the left hand and the right hand side, the function and the expansion, so you can see them, and you work out what that gives you in terms of the function value and the expansion value. Okay, in my case it had a root 97 in, but it had a multiple of root 97, so I just needed to undo that multiple. I hope that makes sense, and it helps.